Okay, welcome to some video support for solving systems of equations by substitution. So in substitution, we have a couple of steps that we'd like to follow. And the first step is that we would like to solve our first equation for y. Secondly, we would like to plug what we find, plug the result into equation 2. Third, solve for x. And then lastly, sub x back in equation 1 for y. Okay, so to begin with, I want to solve the system of equations. I got two simultaneous equations here. One of them is 2x plus 3y equals 80. And the second one is 5x minus 3y equals minus 10. And this is set up so that you can check your work with a method like elimination if you're more comfortable with that. So here, the first thing I need to do is name what my equations are. And my equations here, I've got equation number 1, which is this top line, and equation number 2, which is this second line. And if I follow my steps very well, the first thing I want to do is take whatever equation 1 is, 2x plus 3y equals 80, and I want to get the y by itself, even though that's going to be kind of like getting the slope-intercept form from this equation. It's basically converting the standard form into slope-intercept form. So we won't get an answer here, but we do get something we can use. Okay, so solving this equal to y, I need to subtract 2x from both sides, which has the effect of canceling the x from the right-hand side and moving it to the from the left-hand side, moving it to the right-hand side as such. And then I need to divide off the 3, dividing 3, which has the effect of canceling the 3, leaving me that y is equal to 80 over 3 minus 2/3 x. Okay, and that's what step 1 looks like. I've just solved equation number 1 for y. So this is equation number 1 just in a different form, and I'm going to call it star right now just to refer to the result. Okay, so the second step says I'm supposed to plug that result, what I just did, into equation number 2. Okay, so what that means I need to do is I need to copy down equation number 2. 5x minus 3y should equal to minus 10. Okay. Scooch this over just a little bit. Okay, so what I mean by plugging the result in is I'm just going to take the right-hand side of this equation that I worked, which is 80 over 3 minus 2/3 x, and I'm going to plug that in instead of y. And at this point, I have a multi-step equation, which is in a single variable x. And of course, we know that the way that we solve these is by distributing, combining, and solving. So I'm going to begin by distributing the -3 through this parentheses. A -3 matches the denominators of both, so it's going to flip the sign and leave me with the numerator of each fraction. And the 5x is just along for the ride, as is the -10. And at this point, I've cleared the fractions, and so I'm ready to start combining like terms and then ultimately solving this thing. So 5x and 2x are common to each other, which means I can add them together, leaving me 7x minus 80 equals to minus 10. If I add 80 to both sides, that'll have the effect of canceling the 80 from the left-hand side, moving it to the right and creating a 70. And then, of course, if I divide off a 7, that'll have the effect of canceling the 7 that is attached to the x and reducing the 70 on the right-hand side to a 10, which gives me the result x is equal to 10. Okay? So the next step in our kind of 4-step sequence for substitution is we're going to plug that x back into equation number 1 and just see what comes out to get y by itself. Okay? So I'm going to come over here to this side, and I'm going to copy equation 1 down again. I had 2x plus 3y equals to 80, and I'm supposed to plug the x that I found, this 10 down here in the bottom right-hand corner, plug that in for x, and then I have a multi-step equation in terms of y, and I can solve this to get the y by itself and find the other part of my solution here. So 2 times 10 gives us 20, plus 3y equals 80. If I take 20 from both sides, that will have the effect of canceling the 20 from the left-hand side, moving it to the right-hand side and leaving us with 60. And then if I divide the 3, that'll have the effect of canceling the 3 from the left-hand side stuck to the y and reducing our 60 to a 20. So now I have 2 different answers. I've got x equal to 10 and a y equal to 20. So I just need to put the 2 together in this ordered pair 10, 20 to represent my solution set for this system of simultaneous equations. And notice that that is the x value on the left and the y value on the right. Okay, let me show you a second example. So in our second example, we're going to have kind of a special case. I've got 8x plus 6y equal to 36 as equation number 1. And then I have the second equation, which is 5x plus 6y equals 27. And again, this is set up so that you can like check your work with a method like elimination or something like that. So that should not be too difficult. Okay, so in this particular set of simultaneous equations, what you should notice is that in equation number 1, there is a greatest common divisor for each of the coefficients and the constant in this equation. So when that happens, that just means that we have a straight line which has been scaled to make these numbers bigger. We can actually reduce these because these numbers are bigger, but they're not unique when it comes to representing the line that they represent. I can use smaller numbers to represent the same line. So what I'm going to do is I'm just going to notice that the GCD between 8, 6, and 36 is 2. That's going to let me say, okay, let's not work with this equation. Instead, let's just divide everything by 2. 4x plus 3y equal 18, and this becomes the version of equation 1 that we would like to use. Okay? So then we just follow our steps. Step 1, write down equation 1. 4x plus 3y equals 18. I'd like to get that y by itself. Subtracting 4x from both sides has the effect of canceling the 4x from the left-hand side and then moving it to the right. And then if I divide everything by 3, that has the effect of canceling the 3 from the left-hand side, leaving us with 18/3, which is the number 6, and then minus 4/3 x. Okay, and as you recall from the previous example, I'm going to call this the result of step 1, which we called star. I now need to plug that star back into equation number 2. So what I'm going to do is I'm going to copy down equation 2. Equation 2 says 5x plus 6y is equal to 27. And remember, the result from star goes in this parentheses instead of writing a y down. So that is 6 minus 4/3 x. Okay, so now I have a multi-step equation in terms of x, which I can solve to get my solution for x. I'm going to begin the 5x does nothing. I'm going to distribute the 6 through this parentheses. A 6 times a 6 leaves me with 36. And then 6 times negative 4/3. Well, a fraction is a division and a multiplication simultaneously. 6 divided by 3 gives me 2, and then 2 multiplied by 4 gives me 8. And this was a positive times a negative, so this says minus 8x equals 27. Okay, I can notice 5x and minus 8x are common to each other, so I actually have 36 minus 3x equals 27. If I take 36 from both sides, this will have the effect of canceling the 36 from the left-hand side, which will leave me, whoops, I'm off screen, which will leave me with what appears to be minus 9, actually. And then lastly, dividing by 3 here will give me that x is equal to minus 3, which is my result from the third step, solve for x. Okay, the last step says we're going to copy down equation 1 more time. 4x plus 3y equals 18. And I need to plug the number that I found for x into that parentheses there. So this is minus 3. Okay. Well, 4 times negative 3 is negative 12 plus 3y equals 18. If I add 12 to both sides, that will have the effect of canceling the 12 from the left-hand side, moving it to the right-hand side, leaving me with 30. Dividing by 3 cancels the 3 from the left-hand side and leaves me with a 10 on the right-hand side. So I have two different answers, x equals to negative 3 and y equals to 10. To find my final solution, I need to put them together as an ordered pair with the x component first and the y component second. And there is my solution.